Welcome to online maths lessons by the Maths Online Tutor. Today I am going to teach you about simplifying expressions in algebra. Let's try to understand what is a term and what is an expression is. In algebra, we use letters from our alphabet when the numbers are not known. For example, these are algebraic terms. So 2s and 8y are algebraic terms. Another example is xy, a squared, b squared, 3b squared, 3ab, 3x squared y. They are all algebraic terms. When we write terms like 2s or 8y, for example, we leave the multiplication sign out. So rather than 2 times s, we write 2s. Rather than 8 times y, we write 8y. But if you take 2s for example, it means simply 2 times s. What is an expression? An expression is a string of numbers and letters joined together by mathematical operations such as plus, minus, multiplication and division. For example, r plus 2s is an expression. Here we have two terms added together, and there is a multiplication between 2 and s as well. Another example is a squared plus ab plus b. Here we have some terms joined together in a mathematical operation. Therefore, this is also an expression. I am now going to do an example with you. Suppose that G is the cost of child admission and K is the cost of adult admission to the zoo. Part A of the question. How much does it cost for the Green family of 3 children and 3 adults to visit the zoo? Okay, so the cost of child admission is G, so that is for one child. And the cost of one adult admission is K. There are 3 children and 3 adults. For the 3 children, it costs 3 times by G, which means 3G. And for the 3 adults, it costs 3 times by K, which is 3K. And the total cost is the cost of 3 children plus cost of 3 adults, which is equal to 3G plus 3K. Part B of the question. Write an algebraic expression for the cost for the Norman family of 5 children and 4 adults to visit the zoo. The cost for one child is G and cost for one adult is K. So for 5 children it is 5G, for 4 adults it is 4K. So the total cost will be 5G plus 4K. Okay, let's now move on to addition and subtraction of like terms. Algebraic terms that have the same letter are called like terms. Only like terms can be added or subtracted. For example, 9b, minus 7b and 13b, they all have b term regardless of the number and the sign. So these are all like terms. They can be either added or subtracted depending on the sign. But 60, 5x and minus 11z are not like terms because they have different letters. So they cannot be added or subtracted. For example, apples go with apples, orange with orange. Apples and orange does not go together. So when like terms are added or subtracted, we call it simplifying. I will now try an example with you. Based on our previous example, the Green family and the Normal family visit the zoo together. There are 8 children and 7 adults. 5 children from the Norman family and 3 children from the Green family. 3 adults from the Green family and 4 adults from the Norman family. So total number of adults are 7 adults in the group. Because there are more than 10 people, the families can take an advantage of a special offer, which means minus 1 child can be added free of charge. As before, if we use G for the cost of child admission and K for the cost of adult admission, then the cost for the Green family would be 3G plus 3K and cost for the Norman family is 5G plus 4K. Now we can add total cost for each family together, and we must include the offer of minus G. Because there are more than 10 people in the whole group, the families can take the advantage of the special offer of 1 child to be admitted free of charge. So the total cost will be 3g plus 3k plus 5g plus 4k and the offer of minus g. Now I can add the g terms together. 3g plus 5g minus g is 7g. 3k plus 4k is 7k. So the simplified answer is 7g plus 7k after adding and subtracting the like terms. Okay, let's now try multiplication and division. Algebraic terms and expression can be multiplied in the same way as numbers. However, when we follow a multiplication of the same letters, then we can follow the index rules. There are two main index rules for multiplication and division. For the multiplication, the rule is if the term has the same letter, then regardless of the power, we can add the powers together. Here we have the same term, a term and a term. So the powers can be added together. The answer will be a to the power of m plus n. When there is a division, it is the opposite. If the terms are the same and if there is a division, then the powers will be subtracted. A to the power of m divided by a to the power of n will be a to the power of m minus n. So when we have a multiplication, the two powers adds. When we have a division, the powers subtracted. For example, a times by a is a squared, because the first letter a has a power of 1 and the second a has a power of 1. 1 plus 1 is 2. B to the power of 1 times by b to the power of 1 is b squared. An example for division is a to the power of 5 divided by a to the power of 2. Because it is a division and the same letter, so the power is subtracted. 5 minus 2 is 3. Okay, now I am going to move on to multiplying brackets or expanding brackets. When multiplying expressions in brackets, make sure that everything inside the bracket is multiplied by the term outside the bracket. I will try an easy example first. 2 times by 3x plus 4. The terms inside the brackets are positive 3x and positive 4. The term outside the bracket is positive 2. We can try this step by step. First of all, the term outside the bracket must be multiplied by the first term inside the bracket. 2 times by 3x is positive 6x. Secondly, the term outside the bracket must be multiplied by the second term inside the bracket. Always carry the sign of the second term and the term outside the bracket. So this is positive 2. So when positive 2 is multiplied by positive 4, the answer is positive 8. Next we collect all the terms. If there are like terms, we can collect them. Otherwise, we add the terms together like this, 6x plus 8. And this is our final answer. Okay, now we try bracket to bracket. What happens when we have more than a single term or number outside the bracket? Or what happens when we have another set of bracket? For example, if we want to expand a plus b with c plus d, we need to make sure that everything in the first bracket is multiplied by everything in the second bracket. So let's do this step by step. So the first term in first set of bracket is a. It multiplies with the first term in the second set of bracket. So a times by c is az. Then the first term in the first set of bracket is multiplied by the second term in the second set of brackets. A times d is ad. So the answer so far is ac plus ad. Thirdly, we multiply the second term in the first set of bracket, which is b, with the first term in the second set of bracket, which is c. So b times c is bz. Fourthly, we multiply the second term inside the first set of bracket with the second term inside the second set of bracket, which is d. So b times d is bd. We add them all together. The answer will be ac plus ad plus bc plus bd. Now I am going to try some example questions to improve your understanding about the theory that I have already taught you in algebra. First question is to simplify 5x squared plus 3 minus 2x squared minus 4. Here I can see 5x squared and minus 2x squared. They are like terms because there is x squared term in both of these terms. Regardless of the front number and the sign, these two are like terms. Then the numbers are also they are like terms. Of course, the 5x squared and plus 3 are not like terms, but the numbers with numbers are like terms and x squared terms with x squared terms are like terms. Now I am going to simply follow the BIDMAS or BODMAS operations. 5x squared minus 2x squared is 3x squared. 3 minus 4 is minus 1. So the answer is 3x squared minus 1. Second question. Simplify 9q squared times 2q to the power of 5. I will follow my index rules in this question. Q squared times q to the 5. The powers adds up when there is a multiplication, and when the terms are the same, the powers adds. So 2 plus 5 is 7. Q to the power of 7. 9 times 2 is 18. So the answer is 18 q to the power of 7. Third question. Expand the brackets. I have one term outside the bracket and there are two terms inside the bracket. Multiply each term outside the bracket with each term inside the bracket. 4 times 7 is 28. 4 times 2a is 8a. 28 plus 8a. Last question. Expand the double brackets. Each term in the first set of brackets multiplied with each term inside the second set of brackets. Y times by y is y squared. Y times by minus 4 is minus 4y. Plus 1 times by y is plus y. Plus 1 times by minus 4 is minus 4. Now I collect the like terms. The y terms are like terms. So minus 4y plus y is minus 3y. Other terms I write as it is. So y squared minus 3y minus 4 is the final answer. Okay, today in this lesson I taught you about simplifying expression. I taught you about what is a term, what is an expression, how to collect like terms, how to multiply terms following index rules, how to divide terms following index rules, how to expand brackets, how to expand double brackets. In order to access more questions on simplifying expressions and also other maths topics, please subscribe to my channel. Thank you.